we have both qualitative and quantitative analysis. Let us study first qualitative analysis of organic compound. In qualitative analysis, we are going to study detection of elements, right? So we know that every organic compound having carbon and hydrogen is must. So apart from carbon, hydrogen, there may be a oxygen, there may be a halogen, even there may be a sulfur, there may be a nitrogen, etc. But every organic compound must have hydrogen and carbon. So therefore, then how to detect the presence of carbon, presence of hydrogen and presence of other elements? So we are going to study all qualitative, not quantitative, qualitatively how to identify all these elements, right? So this is also one of the important concept. And if you remember logically, it's very simple. I'll give tabular column type also, how to remember a very easy way. Fine, but before that we'll study in detail everything. Let us see first qualitative analysis of organic compound. It is nothing but you can also write detection of element. Detection of elements. Right, in detection of elements, we have first carbon, hydrogen by one method and remaining elements by another method. So let's see first here A, detection of carbon and hydrogen by copper oxide method. By using copper oxide method, you can detect the carbon and hydrogen. Next, B, we also study detection of other elements like particularly nitrogen, sulfur, halogen by same method, that is a Lessine test. Lessine test. By using Lessine test, we can detect the nitrogen, sulfur and halogen. Okay. C, another element is detection of phosphorus. It has no particular name. Detection of phosphorus by Na2O2, sodium peroxide. Right. So in qualitative analysis, we will study these three detections. Okay. So in detection, 3 points are important. One, since it is a qualitative analysis, so what is the product comes and what is the color of the physical nature of the product is important, right? In the detection of all the elements, for example, detection of like carbon, hydrogen, what is the final product and its color? If any PPT comes, what is the color of PPT? Because since it's qualitative, not quantitative. In qualitative, important is physical property important, particularly color important. Color or smell, right? Physical properties are important. That's you need to remember. Second is chemical equations. So what is the chemical equation in the detection of each and every element? And third most important is exceptions. Like for example, detection of nitrogen. So detection of nitrogen by Lessine test. So this method is not valid for which particular nitrogen compounds? This is question previously bandide, right? One is a physical nature of the product, two chemical equation, exceptions or limitations of the method. Okay, so questions will be based on only three points only. Now let us see first detection of carbon and hydrogen by copper oxide method. Okay, right. So in copper oxide method, organic compound heated with dry copper oxide. Let us take, it is a test tube. Okay, so this is the experimental setup. So in this method, a pure and dry organic compound taken in a dry test tube. This is organic compound, it should be pure and dry. So a pure and dry organic compound taken in a dry test tube, and it is heated with copper oxide. So copper oxide is taken, right, this is a organic compound. So therefore a pure and dry organic compound taken in a test tube, and it is heated with strongly copper oxide. And tell me, as a result what happened? Organic compound containing carbon, no? Okay, carbon oxidized in presence of copper oxide, it gives rise to what? CO2. 1 carbon, 2 oxygen, CO2 plus you will get 2 Cu. So that means carbon oxidized to carbon dioxide. The hydrogen present in the organic compound also undergo oxidation, it forms water plus Cu will be byproduct. Okay, that means when organic compound is heated strongly with copper oxide, carbon oxidized to carbon dioxide, hydrogen oxidized to water. Okay, then how to detect hydrogen and that is how to detect carbon dioxide and water? Now detection of water, let's see. Tell me, how do you detect water? Now here water is formed and CO2 also formed. Now this CO2 and water, it is passed over the anhydrous copper sulfate. We know that anhydrous copper sulfate is a colorless, but when water is passed over anhydrous copper sulfate, this anhydrous copper sulfate absorbs the water. Yes or no? It absorbs the water and it becomes hydrated copper sulfate blue. So the appearance of blue indicates presence of water. And next is carbon dioxide. Carbon dioxide, now it is passes through the lime water. So this lime water turns, it's milky, no? Milky white. Therefore when the lime water turns milky white, it indicates presence of CO2. So in this way you can identify the presence of CO2 and presence of what? Carbon dioxide. Okay, now see the reaction. This is organic compound containing carbon. It is organic compound containing hydrogen. The organic compound containing carbon oxidized to carbon dioxide, hydrogen oxidized to water. Now this carbon dioxide passed through the lime water. What is the reaction? Carbon dioxide plus calcium hydroxide, which gives rise to calcium carbonate. This is a milky white substance. Yes or no? Next, what about water? So water is absorbed by the anhydrous copper sulfate. Anhydrous copper sulfate is a colorless. It is a colorless. But when anhydrous copper sulfate absorbs the water, it becomes CuSO4 5H2O. This is a blue color substance. Therefore this copper sulfate turns blue color, which indicate presence of what? Hydrogen. Water. Presence of water, nothing but it indicates the presence of hydrogen. Okay, then you can make this is a tabular column. 1. Experiment. Observation and equation. Equation मतलब reaction. Reaction, then inference. Tell me, in the experiment, let us see first detection of hydrogen. Tell me, for the detection of hydrogen, what is experiment? Organic compound is heated with what? Copper oxide, no? Copper oxide. Do you understand? See, for detection of hydrogen and carbon, same experiment. The organic compound is strongly heated with copper oxide. As a result, what happened? Carbon oxidized to CO2, hydrogen oxidized to water. So therefore, in the detection of hydrogen, what is the experiment? Organic compound, which is heated with what? Copper oxide. So organic compound plus copper oxide heated strongly. So what is the observation? What is the observation? Hydrogen, no. Anhydrous copper sulfate turns to blue. So what is the reaction? Reaction is here 2 hydrogen plus copper oxide will get water plus, of course, water plus copper. Then this water absorbed by the copper sulfate, it is a colorless, it turns to copper sulfate 5H2O. What is the inference? Presence of hydrogen confirmed. That's it. Only these 4 things are important. Next. So detection of carbon. So in the detection of carbon, again same experiment. Organic compound plus copper oxide heated strongly. Right. So organic compound plus copper oxide heated strongly. Then tell me, what is observation? So lime water turns milky white. So reaction. So same this and this. Right. That is carbon plus 2 copper oxide gives us to CO2 plus 2 copper, and this CO2 passed through the calcium hydroxide, right, which gives us to calcium carbonate. This is a milky white. So presence of carbon confirmed. Okay. So it is the detection of both hydrogen and carbon by copper oxide method. Next. So detection of nitrogen, halogen and sulfur. Detection of nitrogen, sulfur, halogen. Here particular method by Lessine test. So Lessine test also called sodium fusion test. Sodium fusion test. Okay. So what is Lessine test or sodium fusion test? Right. So to perform the Lessine test, sodium fusion test, first we need to prepare the sodium fusion extract, which is called Lessine extract. Okay, that is the first step. So preparation of sodium fusion extract is the first step. By taking sodium fusion extract, you can identify you can detect the nitrogen, sulfur, halogen separately. So therefore the first step is preparation of sodium fusion extract. It is called SFE, sodium fusion extract. So how do you prepare sodium fusion extract? Okay, see here. To prepare the sodium fusion extract, a small piece of sodium metal taken in a fusion tube. So fusion tube is a small test tube. It's just like test tube, but test tube is 10 ml now. It is around 2 to 3 ml. It's very small. So 2 to 3 ml small test tube will be there. Of course, it is a very hard. Compared to test tube, it is a harder one. So which is called fusion tube. So a small amount of sodium metal. Okay, sodium metal, it is taken in a fusion tube. So it is called fusion tube, and it is heated very strongly until it melts. So until it melts, it is heated strongly. Okay, then next to this, a small amount of organic compound is added. Listen carefully, important. So in the preparation of sodium fusion extract, what we are doing is a small piece of sodium metal. We know sodium metal is highly reactive, right? A small piece of sodium metal taken in a test tube, and it is heated strongly until it melts. Okay, so after it is melting, then a small amount of organic compound is heated. Again it is heated, compound added. Again it is heated nearly 2 to 3 minutes until both will completely mix, and it become red hot. This tube become red hot. Okay, now it become a red hot fusion tube. Now this red hot fusion tube, right, it has what? Mixture of both sodium metal and organic compound. Now this red hot tube, now it is poured into the china dish. Okay, china dish, it is containing water, right? Right, so this red hot tube is poured into the china dish, and it is crushed as well as cooled. Then later it is filtered. The filtrate is called SFE, sodium fusion extract. Do you understand? Now this is a red hot fusion tube. Now red hot fusion tube. This red hot fusion tube is poured into the china dish, right? It is poured into the china dish, and it is crushed. Okay, crush ಮಾಡಬೇಕು. After crush, it should be cooled down. Then later it is filtered. Okay, then whatever the filtrate will come now, that filtrate is called sodium fusion extract. That filtrate is separated in a beaker. It is SFE. Now this SFE is used to detect the 3 elements. One is a nitrogen, sulfur, and all halogen, chlorine, bromine, iodine. Now tell me, sodium fusion extract contain which element? There may be an organic compound like hydrogen, carbon, hydrogen, nitrogen, all will be there. And along with that, there is a sodium. Then what is the purpose of heating the organic compound with sodium? No, it is nothing but we are heating the organic compound sodium. No, what is the purpose? So organic compound is a covalent compound, right? It is a covalent nature, covalent compound. So covalent compound has to convert into ionic compound by treating with sodium. Therefore in this method, the covalent compound, organic compound, it is converted into ionic compound. So what is ionic compound? We'll study now. Okay, that's one important conversion will be there. Now let's see detection of nitrogen. detection of nitrogen. Then detection of, now tell me, to detect the nitrogen what we take? SFE. We don't take organic compound now. The organic compound we have converted into ionic compound, right? We take this mixture SFE, sodium fusion extract. So therefore now in the detection of organic compound, a small amount of SFE, sodium fusion extract, so small amount of sodium fusion extract taken into the test tube. This is a SFE. Okay, take this is the one. To this SFE, next 2, freshly prepared ferrous sulfate is added. It is the second reagent. Then next it is mixed with small amount of FeCl3. It is a third reagent. And fourth, finally it is mixed with or it is treated with dilute hydrochloric acid. This is a 4. It means in the detection of nitrogen we add total 4 reagent. One is the SFE. To this SFE what we add? Sequence also important because reactions we write now. To this SFE we add ferrous sulfate. This is freshly prepared ferrous sulfate is used. Next, to this now mixture we add small amount of FeCl3. Then this reaction is acidified, means it is treated, the whole mixture is treated with dilute hydrochloric acid, which is called acidified. Okay. Then now what is the reactions? Questions based on reactions important. To understand reaction you need to remember this sequence. Okay. Now tell me, now there is a SFE. First of all we need to understand SFE contain what? Okay, now we know that every organic compound containing carbon. Okay, then every organic compound has hydrogen, but we don't want hydrogen now here. Carbon will be there, and there will be a sodium we added actually. Okay, and if organic compound containing nitrogen, okay, because organic compound containing carbon, sodium we added. If organic compound containing, you write, if organic compound contain nitrogen, and tell me, if organic compound contain nitrogen, carbon will be there. Okay, nitrogen will be if it is there, then sodium we added. What it forms? It is a NaCN, no, sodium cyanide. Now this is organic compound. It is actually covalent nature, organic compound. Sodium cyanide, ionic nature. So in this way, organic compound, covalent compound converted into ionic compound, sodium cyanide. So therefore, when you take sodium fusion extract containing what? Sodium cyanide. Already it is present, sodium cyanide. Now to this sodium cyanide, nothing but SFE. It is nothing but our SFE. Okay. To this sodium cyanide, what we added second? FeS. Ferrous, freshly prepared ferrous sulfate is added. Therefore, now tell me what is the possibility? Fe plus 2, no? Therefore, it forms, it is a plus 2, Cn twice should be there. Okay, ferrous cyanide plus 2 sodium, 2 sulfate will get Na2SO4, which is called sodium ferrous cyanide. Okay. Next, to this ferrous cyanide, what we added? So we added, now next is FeCl3. That's what sequence also important. Now, before that, let us take ferrous cyanide. This ferrous cyanide again reacts with 4 moles of sodium cyanide. You'll get it is Na4 FeCN6 it is 4, which is called sodium ferrocyanide. You have studied in where coordination compound. It is a ferrona, ferrina. If it is a 3, it comes ferri, because actually it is a -4, no. If it is a -4, you will get +2. So this is a sodium ferrocyanide. So this is the intermediate. Sodium ferrocyanide will be formed. When this is formed? Tell me. When ferrous sulfate is added to sodium fusion extract. Okay. Next, now to this what we are adding? FeCl3. Sodium ferrocyanide already present. Names are important. Sodium ferrocyanide already present. Now which is mixed with FeCl3? Tell me, in FeCl3, Fe is a +3. This Fe +3 and sodium Na plus both are interchanged. Both are exchanged. That means Na plus replaced by Fe +3. Okay. Then tell me what may be the product. Fe +3 and FeCN6 -4, no? This is -4, no? So in crisscross method, what do you get? This 4 comes here, this 3 comes here. Now which is called, this is ferri, no? Ferri ferrocyanide. Name is important. Ferri ferrocyanide. So ferri ferrocyanide, its common name is Prussian blue. Very, very important. Prussian blue. It is actually bluish green color substance. Okay. So the appearance of Prussian blue indicates or confirms the presence of nitrogen. Okay. Then now what is the function of HCl? I'll tell you. Function of HCl is, see, in this whole equation, organic compound treated with sodium, right? You'll get sodium cyanide, right? In this reaction, this sodium also reacts with water. Where water is present? We are not adding water, no? Water will be there. There is a hydrogen, no? Organic compound containing hydrogen and oxygen will be there, right? So and that hydrogen oxygen may combine, it forms water, because when organic compound heated, obviously water will come out. That water may react with sodium metal, it become basic nature. So to neutralize that, we add acid. That means acid makes neutral condition, because if there is a possibility of formation of sodium hydroxide, because sodium is there, water will be producing in organic compound. Therefore to neutralize that, we add what? Dilute HCl. It is called acidified. Only the whole solution is acidified. Okay. Now tell me here, what is the experiment? First take reaction, then observation. Inference. Tell me, what is experiment? SFE mixed with ferrous sulfate, then FeCl3, then dilute HCl. Okay. Then what is the sequence of reaction? SFE containing sodium cyanide. Now which is reacts with FeSO4, which gives rise to FeCN twice, ferrous cyanide. Next, ferrous cyanide, it is reacts with excess of sodium cyanide. It gives rise to sodium ferrocyanide, Na4 FeCN6. This sodium ferrocyanide Now it is treated with ferric chloride, FeCl3, which gives rise to most important compound is Fe4 FeCN6 tries. So most of the students get confused this formula. Okay, to remember formula, better remember name of the compound. It is a ferric ferrocyanide. So we know ferric is what? Fe plus 3, ferric. Ferrocyanide is FeCN6 minus 4. Ferrocyanide. Ferricyanide is minus 3 comes. Therefore, ferric ferrocyanide. So in crisscross method, you will get this formula. This is also called Prussian blue. It is a bluish green color substance. And observation, Prussian blue or bluish green color solution is formed in presence of N2 confirmed. Now N2 just nitrogen, right? Okay. Now here there is a limitations of this reaction. Limitations, or else you can write under note. Note. And tell me here, first point. And tell me why the organic compound is strongly heated with sodium metal. Why it is necessary to prepare sodium fusion extract? Can't you take directly organic compound and mix FeSO4? Is it organic compound reacts to FeSO4? May not. Because ionic compounds can react easily, not covalent compounds. So therefore, the purpose of preparation of SFE is to convert organic compound into ionic compound. So therefore, in SFE, covalent compound converted into ionic compound. So what is ionic compound? Sodium cyanide. Actually we are using sodium cyanide. We are detecting sodium cyanide. Next, second point. And tell me, this method is not applicable for which organic compound containing nitrogen? 1. This method is not, this test is not possible or not applicable for the diazo compounds. Why? This method is not applicable for the diazonium salt, diazo compound, diazonium salts. Why it is not applicable for diazonium salts? Because benzene diazonium chloride, we know when benzene diazonium chloride, it is just heated. When it is just heated, what happen? NO2 come out. NO2 gas, N2 gas is come out. Okay, so since N2 gas is liberated, this N2 gas do not form NaCN, because our nitrogen compound has to convert into what? NaCN. So this N2 gas, it escape out, so it cannot be react with sodium metal. It does not form sodium cyanide. When sodium cyanide is not formed, this reaction is not possible. Next, that is one limitation. Second limitation, this method is even not possible for hydrazine. It is not possible for hydrazine. What is hydrazine? NH2, NH2. And it is not possible for hydroxyl amine. Why? Even though there are nitrogen, N is there, N is there. This hydrazine does not form N2, does not form nitrogen gas. It form like sodium cyanide. Here also it does not form N2 gas, even though not possible. Tell me, This sodium, no, SAF containing what? Sodium cyanide. Can this compound form sodium cyanide? No. Why? Sodium will be there, N is there, but carbon is not there, no. If there is a carbon plus nitrogen, then sodium, you will get sodium cyanide. These two compounds do not have carbon itself. When they do not have carbon, so this method is not possible. They do not form sodium cyanide, they do not form, these kind of reactions. Therefore, it is not possible for hydrazine, not possible for hydroxyl amine. Okay, next. Now, as we discussed, so in this method, dilute HCl is added finally. So why usually it is added? Because so in this reaction, sodium metal is added. That sodium metal reacts with water, it forms sodium hydroxide. So that to neutralize the sodium hydroxide, a small amount of dilute hydrochloric acid is added. Okay. Next, one more important point. Then suppose if organic compound containing small amount of nitrogen, if organic compound containing a very small amount of nitrogen, then you will get pressure, then you will get the compound. This compound will be formed, but this compound will be formed not like precipitate. It is formed as a colloid. Actually, this is a not solution, PPT. Okay, it doesn't form as a precipitate, it form as a colloid. So when it formed as a colloid, now its color changes. So Prussian blue actually bluish green. So it becomes only blue color. So the compound color become blue when the quantity of nitrogen is very less in organic compound. So these are the some important point. Question can be expected from this. Now everybody can remember these equations and the color and all, but most of them you people confuse remembering these points. Okay, so first point you understood. Second point, tell me. Second point is this method is not applicable for diazonium salts because they produce N2 gas which do not convert into sodium cyanide, because we wanted sodium cyanide. Next, 3. Now question will be like this: which of the following is not detected by Lessine test? Compound will be there: benzene diazonium chloride, hydrazine, hydroxylamine, all. These are questions. Next, third one is this method is not applicable for one hydrazine, that is N2H4, hydroxylamine, because they do not contain carbon atom. To form sodium cyanide. Next, in this test, dilute HCl is added to neutralize the basic nature. So to neutralize the basic nature of SFE, because SFE has basic nature, sodium hydroxide will be produced. Next, fifth one. So fifth one is, if organic compound contain a very small amount of nitrogen, it forms the Prussian blue, it forms the ferric ferrocyanide, but colloidal form. Otherwise it is a precipitate, right? It forms colloidal form. So when it forms colloidal nature, its color is blue color, not bluish green, right? Therefore if organic compound contain small amount of nitrogen, Fe4 FeCN6 twice ferric ferrocyanide formed as a colloidal substance which is blue in color. Which is blue in color. Write in question. Which of the following nitrogen compound can be detected by Lessine test? 1. BDC, benzene diazonium chloride. 2. Hydrazine. 3. Hydroxylamine. 4. D. Aniline. Which can be detected? Aniline. So aniline nitrogen can be detected but not remaining compounds. Okay, next. So detection of sulfur. Okay. Next is detection of sulfur. Okay. Now tell me, if organic compound containing sulfur, if the organic compound contain sulfur, then what is the product in the Lessine test? In Lessine test there is a sodium, we are adding carbon will be there, and tell me, and next sulfur will be there, no? If sulfur is there, now tell me, if the sulfur is present, what it forms? There is a possibility of Na2, yes, of course carbon will be there. Carbon does not reacts with sulfur or even sodium, that sodiums are already finished. So therefore, if organic compound containing sulfur reacts with sodium, it forms sodium sulfide. So this is a covalent compound, sulfur present in covalent compound, it become ionic compound. Now we need to detect the presence of what? Sodium sulfide. So therefore now detection of Na2, yes. There are two methods. One, lead acetate test, even we do in organic chemistry. This is simple test, lead acetate PbCOO twice. B, sodium nitroprusside test. Sodium nitroprusside. So what is a sodium nitroprusside? Na2 FeCN5NO. The name of the compound and formula important. Sodium nitroprusside test. These are the two tests for detection of Na2S. Okay. Now let us see. First one is detection of sodium sulfide by lead acetate. Okay. So in this test, SFE means nothing but Na2S. SFE treated with lead acetate, that is a sodium sulfide, it is present in SFE treated with lead acetate. Tell me what is the possibility? Sodium is a positive, acetate is negative. S is negative, lead is positive. We will get a PbS. This is a black PPT. Sulfide, heavy metal sulfides are black PPT. Lead sulfide, copper sulfide, silver sulfide, all sulfides are black precipitates. And the remaining is 2 moles of acetic acid. It confirms presence of sulfur. 1 mole sodium, okay. Sodium acetate. Next, sodium nitroprusside test. Na2 FeCN5NO. It is a sodium nitroprusside. By using sodium nitroprusside, again you can identify detect the lead sulfide, sodium sulfide. Tell me how? Sodium sulfide, where it is present? SFE. Okay, small amount of SFE. So small amount of SFE taken in a test tube and which is mixed with what? Sodium nitroprusside. Okay. यार बंदर आ रहा किधर है? यार बंदर. Nobody. ಯಾಕ್ರೆ ಬರೋದು ಹೋಗಿ ಮಾಡ್ತಿದ್ದೀರಿ? Okay, tell me now. Listen here. Now here product is, you will get the product with violet color. So important is color and its formula. Come on, tell me. See here, Na2, it is just addition, Na4. Very simple. And Fe, let it be Fe only. Next, CN5, it will be same, CN5. Then NO is there, no? This NO and S, it converts into NOS. This is a violet color precipitate. Okay. So question is like this: which of the following is a violet colored substance produced by sodium nitroprusside test in the detection of sulfur? This formula is important. So to remember this formula, you need to remember this. This is what? Sodium nitroprusside. So to this sodium nitroprusside, we are adding 2 sodium here, 1 sulfur here. That's it. Other things are same. So these two are the test for detection of what? Sulfur. Okay. Next, one important note. Important note is, see, sometime organic compound containing both nitrogen and sulfur. Possible, no? Organic compound may contain both nitrogen as well as sulfur. So let's see that condition. If organic compound contain both nitrogen and sulfur, Then how do you detect? Okay. So if organic compound contain both nitrogen and sulfur, so it can be detected. Organic compound contain, of course, sodium we are adding, carbon will be there, and nitrogen if it is present, sulfur also present. Tell me, this is in where? SFE. Okay, organic compound containing carbon. So nitrogen, sulfur, if they are present and we are adding sodium, what is the possibility of the compound? So sodium thiocyanate, right? So here sodium thiocyanate is the product present in where? SFE. Okay. Now how this can be detected? It can be detected by adding FeCl3, small amount of FeCl3. Let us take sodium thiocyanate, and to this FeCl3 added, you will get the complex compound FeCNS, and it is Cl2. This is a blood red color complex. Okay, it is not balanced, you can balance it. Balanced, no. One sodium, one Cl, Cl2 is okay. So therefore, the appearance of blood red color indicates presence of both nitrogen and sulfur, right? It is a detection of sulfur. Now detection of nitrogen over detection of sulfur. Next is detection of halogen. It is very simple. Now next, third one is C, detection of halogen. So in halogen particularly, chlorine, bromine, iodine can be detected, not fluorine. Okay, so fluorine compounds we do not touch. ಏನಾಗೋದು ಗೊತ್ತಾಗಲ್ಲ. Okay, fluorine is a doubt ಬಂದರೆ ಮುಟ್ಟಲ್ಲ. Okay, so detection of halogen, that is chlorine, bromine, iodine. Now tell me, if organic compound containing halogen, if organic compound contain halogen, so what is the product formed in Lessine test? ಏನು ಬರುತ್ತೆ ಹೇಳಿ? Sodium we are adding plus if halogen is present X, it form NaX. For example, sodium is added if chlorine present, sodium added bromine present, and sodium plus iodine present, it is a NaCl, NaBr, NaI will be formed. Now task is how to identify NaCl, NaBr, NaI. Very simple test, silver nitrate test, AgNO3 test. So therefore now test for identification of sodium halides. Test for detection of NaX. So what is the name of the test? Silver nitrate test. Of course, it is a costly test because silver is there now. Silver is costly. Okay, but you will get a very accurate result. Yes. Fine. Silver nitrate test. Tell me, if organic compound containing like sodium chloride, okay, NaCl. If organic compound containing chlorine, it form NaCl. Now this NaCl is treated with silver nitrate, then tell me what is the possibility? Immediately a white PPT of AgCl will be formed, then remaining is what? NaNO3. Okay, but once in NEET question asked that, question is this, okay, white PPT formed, but further one more question is added. This white PPT whether dissolved in excess of ammonium hydroxide or not. If it is dissolved, what is the complex? Okay, say remember, among AgCl, AgBr, AgI, silver chloride is completely soluble or dissolved in ammonium hydroxide, excess of ammonium hydroxide, whereas silver bromide is partially soluble and silver iodide is insoluble. So it is the solubility of silver halides in excess of ammonium hydroxide. Now therefore it is soluble. Now tell me, AgCl and which is soluble excess of ammonium hydroxide, then what is the product? It forms, you all know it, tell me, plus and okay, you will get OH minus and of course HCl. This is Tollens reagent, no? Ammonical silver nitrate solution is called Tollens reagent. Yes, it is a detection of aldehydes. So therefore, now due to formation of this compound, AgCl soluble in ammonium hydroxide, silver chloride soluble in excess of ammonium hydroxide, it forms Tollens reagent. Next, if there is a sodium bromide, tell me, sodium bromide also reacts with silver nitrate, what is the product? Is AgBr. What is the color of AgBr? It is a light pale yellow, right? Light yellow or pale yellow, not dark yellow. Then NaNO3 will be the byproduct. Now tell me, this pale yellow precipitate, is it soluble in X of AgNO3? It is partially soluble in excess of ammonium hydroxide. Okay, next is, if there is a iodine, sodium iodide also reacts with AgNO3, what it forms? Silver iodide. So what is the color of silver iodide? It is a pale yellow, dark yellow it is, dark yellow colored. Dark yellow PPT, black. Okay, so this is a detection of halogen. It is so simple. Last one is detection of phosphorus. Okay, tell me, in the detection of nitrogen by Lesson test, what is the color of the final product? I asked color, bluish green. What is the name of the product? Prussian blue. What is the formula? Fe4 FeCN6 trice. Formula is important. Okay. Next, in the detection of both nitrogen and sulfur, what is the color of the product? Red color. Which red color? Blood red color. What is the formula? FeCNS Cl2. Cl2. Okay. Cl2. Right. Next, in the detection of chlorine, okay, by silver nitrate test, what is the color of the precipitate? White PPT. Next, bromine, pale yellow. Iodine, dark yellow. Okay. Next one is detection of phosphorus. ಯಾರಿಗೆ ಹೋಗ್ಬೇಡಿ. Okay, detection of phosphorus. Right. So detection of phosphorus. Tell me. So phosphorus can be detected by Na2O2 test, sodium peroxide test. Okay, right. So here the test is like this. Sequence of reaction will be there. Right. So it is a dry test tube. It is organic compound containing phosphorus. It is not by lesson test. Lesson test is completed. So we have taken directly organic compound which containing phosphorus. Right. Organic compound containing phosphorus taken directly. Okay, this is a one, and to this a small quantity of Na2O2 is added. What is Na2O2? Sodium peroxide. See here, when sodium peroxide is added to organic compound containing phosphorus, this phosphorus reacts with Na2O2, will get sodium phosphate. There is sodium, it is phosphorus, you will get sodium phosphate. Okay, first compound. Next, this is 2. Now to this mixture, thirdly we add concentrated HNO3. Tell me. Now already we have sodium phosphate. That sodium phosphate now reacts with concentrated nitric acid, it gives phosphoric acid. Sodium phosphate become phosphoric acid, is also called orthophosphoric acid. Now finally, to this orthophosphoric acid we add ammonium molybdate. Ammonium molybdate. Then finally it forms sodium phosphoammonium molybdate. Okay, which is a yellow in color. Right. So therefore we need right now sequence of reactions. Tell me more. Now tell me organic compound containing phosphorus. Now let us take I'll take directly phosphorus. Organic compound containing phosphorus. Now which is reacts with Na2O2. What it forms? Na3PO4. Okay, tell me. So what is the byproduct? What is the equation, balanced or not? So take 2 phosphorus and here 5, then you'll get 2 plus 2H2O. Now it is balanced. It is sodium phosphate. Reactions only important. Now sodium phosphate Na3PO4, which is reacts with HNO3. So we added HNO3. And tell me, HNO3 reacts with sodium phosphate, what it forms? This sodium replaced by hydrogen. So you'll get H3PO4. So how many 3 moles? 3 sodium, 3 NO3, Na, NO3, 3 moles. Yes or no? Now this is what? Phosphoric acid, which is also called orthophosphoric acid. Phosphoric, not phosphorus. H3PO4. Okay. Now this phosphoric acid further treated with ammonium molybdate. Okay. So NH4 twice molybdenum. Ammonium molybdate, which is also reacts with excess of HNO3 will be there, which gives rise to ammonium phospho ammonium phosphomolybdate, plus you'll get 12 H2O. Okay, this is a yellow PPT. So this is the separate test for the detection of phosphorus. Okay. Here you need to remember this formula of the compound. So most of the time they will give the color. Yellow color precipitate will be formed in detection of phosphorus so and so by adding reagent. So what is the formula of the compound? Okay, so formula will be asked. Okay. Now tell me. So we have written tabular column for what? Detection of hydrogen and carbon, and we have written detection for nitrogen also, right? Okay. Next, right, detection for sulfur not written, no? Okay, write the tabular column. Now write the tabular column in the same sequence: experiment, observation, inference. No, in between that you write equation also. Experiment, then equation, observation, right? Experiment, observation, equation or reaction, observation, next inference.